Welcome back, deep divers. Ready for another prehistoric adventure? Today we're diving into an extinction event you might not have heard much about, the Aptian Extinction.
Yeah, it doesn't have the same ring to it as the one that wiped out the dinosaurs, does it?
Not quite as catchy, but trust me, it's got its own twists and turns. We're talking massive volcanic eruptions, shifting ecosystems, and a whole lot of scientific head-scratching.
It's a real puzzle, this one.
So picture this. It's the early Cretaceous period. Dinosaurs are ruling the Earth. We've got those massive long-necked sauropods lumbering around.
And of course, the fierce meat-eating theropods.
Right. Life is good, the ecosystem is thriving, but hold on tight because things are about to get shaken up. Literally.
Enter stage left, the Ontong Java Plateau eruption.
Oh yeah, this is a big one.
About 125 million years ago, this volcanic giant in the West Pacific unleashes a truly mind-boggling amount of magma.
We're talking one of the largest volcanic events in the past 200 million years.
To put it in perspective, the amount of magma ejected would be enough to bury the entire United States under a layer several kilometers thick.
Seriously.
Seriously, and it doesn't stop there. Fast forward a few million years to about 117 million years ago, and we get another eruption, the Kerguelen hotspot,
Where's that one?
what is now India.
Okay, so another massive eruption. You'd think we'd be looking at a mass extinction on par with the dinosaurs' demise, Darnie.
You'd think so, wouldn't you? But that's the curious thing about the Aptian extinction. It was surprisingly underwhelming.
Underwhelming for a volcanic event at that scale.
I know, right? It's a real head-scratcher.
Yeah.
Even figuring out which species were hit hardest is a challenge.
So some marine life took a hit.
Some, yes. Certain types of plankton and algae. But the impact wasn't enough to wipe them out completely. It's almost as if life on Earth just shrugged and said, volcanoes, we've dealt with worse.
Even the extinction of sea crocodiles and stegosaurs, which were already on the decline, barely registers on the extinction scale.
Exactly. It's a strange situation. It's like someone tried to throw a massive extinction party, but only a handful of guests showed up.
So where's the drama? What's the big takeaway from this seemingly uneventful extinction event?
Well, here's where things get interesting. The Aptian extinction, while not a major killer, may have been a turning point for plant life.
Okay, now we're talking. Tell me more about this botanical twist.
Before the extinction, forests were dominated by a specific type of conifer, benetiles.
Benetiles. Got it.
And two ferns, of course. Cycads, ginkgos, seed ferns, they all played a role.
Usual suspects.
Right, but flowering plants were just starting to emerge.
So picture a world of ferns and conifers with flowering plants just beginning to make their debut. What happens next?
Well, those volcanic eruptions, they dealt a blow to these dominant plant groups, shook up the status quo, so to speak. And this created an opportunity for a new era of plant dominance.
Ah, so the underdogs had their chance to shine.
They did indeed. Flowering plants took advantage of this opening and began their journey to becoming the dominant plant group we see today. It's like an underdog story, with volcanoes playing the role of the unexpected game changer.
That's incredible. It's amazing how events that seem purely destructive can actually pave the way for such significant evolutionary shifts.
It's all about adaptation and opportunity.
Now, I have to ask, why was the Aptian extinction so mild? Do scientists have any theories about that?
There is a fascinating hypothesis that suggests Earth experiences a major extinction event roughly every 26 million years, like clockwork. And wouldn't you know it, the Aptian extinction lines up pretty neatly with this cycle.
Interesting. So maybe this extinction was just Earth hitting its reset button. And did the volcanic eruptions just happen to coincide with this natural cycle, amplifying its effects?
It's definitely a possibility. And even though it wasn't a mass extinction, the Aptian extinction still reshuffled the deck in subtle but important ways. It set the stage for the rise of new dinosaur lineages that would rule the late Cretaceous, leading to the iconic dinosaur world we often imagine.
So even though it wasn't a mass extinction, the Aptian extinction still played a crucial role in shaping the world of dinosaurs. It's a good reminder that even seemingly small events can have ripple effects that echo through millions of years. Now let's turn our attention to another intriguing extinction event that occurred during the late Cretaceous, specifically during the late Cenomanian and Turonian ages.
This one is called the Cenomanian-Turonian extinction event, and it's closely tied to a dramatic rise in sea levels. That's right, picture this. This is the Cenomanian-Turonian boundary roughly 94 million years ago. Sea levels were reaching heights not seen for millions of years, even higher than today's levels. Coastlines swallowed by the ocean, vast stretches of land submerged beneath the waves. It was a dramatic reshaping of the planet.
Okay, I'm getting some serious Waterworld vibes here. But how did rising sea levels lead to an extinction event? Was it like a giant tsunami wiping everything out?
Not exactly a tsunami, but the effects were still profound. The rising seas altered ocean currents, which had a ripple effect on global temperatures. Tropical regions in particular experienced a significant cooling, and this combined with other factors led to what we call Oceanic Anoxic Event 2, or OAE2 for short.
Oh, AE2, that sounds ominous. What exactly happened during this event?
Well, the name gives you a clue. Anoxic means without oxygen during OAE2, vast stretches of the ocean became oxygen depleted. It's as if these areas were suffocating.
So no oxygen, no party for marine life.
Exactly. Marine organisms, especially those adapted to oxygen-rich waters, faced a real struggle for survival. We see evidence of this in the fossil record with a decline in the diversity and distribution of certain species.
Are there any specific examples that come to mind? Some poor creatures that really felt the squeeze, so to speak?
Ammonites, those fascinating cephalopods with spiral shells, are a prime example. While generally resilient, their diversity and distribution had been declining since the beginning of the Cenomanian OAE2, delivered a significant blow, pushing them further down a path that would eventually lead to their extinction at the end of the Cretaceous.
So rising sea levels, changing ocean currents, and oxygen depletion. It sounds like a recipe for disaster. But wait, there's more, isn't there? Enter.
Yellow volcanoes?
You know it. As if rising sea levels weren't enough. A massive submarine volcanic eruption threw even more chaos into the mix. This eruption believed to have occurred in the Caribbean. Large igneous province spewed enormous amounts of lava and gases into the oceans.
A submarine volcano. That sounds intense. I bet things were really heating up in the oceans, literally.
You bet. This eruption caused a rapid spike in ocean temperatures, reaching some of the highest levels recorded during the Cretaceous. But more importantly, it exacerbated the already existing problem of oxygen depletion.
So it was a double whammy for marine life. No oxygen and scorching temperatures. Talk about a bad day at the beach. Indeed, this combination of factors, rising sea levels, ocean deoxygenation, and a massive volcanic eruption, led to the Cenomanian-Turonian extinction event, also known as the Bonarelli event, after the distinctive black shale layer found in geological records from this period.
Black shale. That sounds pretty ominous. I guess that's not the kind of souvenir you want to bring back from a prehistoric vacation.
No, not exactly. This black shale is a testament to the widespread death and decay that occurred in the oceans during this time. It's a stark reminder of just how interconnected Earth's systems are and how even seemingly small changes can have major consequences.
So how bad was the damage? How many species waved goodbye during this extinction event?
It's estimated that between 7% and 8% of shelled species and 17% to 26% of genera went extinct during this time. Deep-sea organisms such as foraminifera, bivalves, and radiolarians were particularly hard hit with extinction rates ranging from 20% to 80%.
Wow, those are some sobering statistics. Did any groups manage to escape relatively unscathed?
Interestingly, the Cenomanian-Turonian extinction event had a distinct geographical bias. The extinctions were concentrated in warmer tropical and subtropical regions. Polar regions, located above and below 60 degrees latitude, remained relatively unaffected.
So while life in the tropics was struggling, things were relatively chill at the poles. It's fascinating how even extinction events can have such distinct patterns.
Exactly. This geographic pattern highlights how changes in ocean circulation and temperature gradients played a key role in driving this extinction.
It's a powerful reminder of how interconnected our planet is and how events in one part of the world can have repercussions across the globe. But let's not lose sight of the survivors who managed to weather this storm.
Well, despite the significant losses, many groups did survive the Cenomanian-Turonian extinction, and their recovery played a vital role in shaping the future of marine ecosystems. For example, while ammonites suffered a setback, they persisted, albeit with reduced diversity, for millions of years.
So it wasn't a complete knockout for the ammonites. They were down, but not out.
Precisely. And this extinction event opened the door for the rise of new groups. Bony fish, for instance, which were already diversifying, continued to thrive in the aftermath, eventually becoming the dominant group of marine vertebrates.
It's incredible how life finds a way to bounce back, even after such dramatic upheavals. But before we get too optimistic, I believe there's another extinction event lurking in the late Cretaceous, right? One that's a bit more famous.
You're talking about the big one, the end Cretaceous extinction that wiped out the non-avian dinosaurs. It took place during the Maastrichtian stage, the last stage of the Cretaceous period, and it's closely tied to, you guessed it, Another massive volcanic event.
Okay, so it's back to the volcanoes. But this time we're not talking about just any eruption. We're talking about the Deccan Traps in India, right?
You got to Deccan Traps eruptions were one of the largest volcanic events in Earth's history.
Right.
It's a story of fiery destruction, ecological upheaval, and, of course, extinction.
Well, that sounds like a perfect segue into our final segment. After a short break, we'll explore the Deccan Traps eruptions and their role in the end of the dinosaur era. Stay tuned. All right, deep divers, we're back and ready to wrap things up, talking about these crazy Cretaceous extinction events. We've already talked about the Aptians, right? And that Cenomanian-Turonian one, too.
Lots of long names.
Definitely. But now we're finally here at the end of the Cretaceous period, the Maastrichtian stage. This one's the big one, the one that brought the curtain down on the dinosaurs.
Yeah, the one that everyone knows.
And we know this one was a doozy. It's closely linked to, you guessed it, another massive volcanic eruption.
Back to the volcanoes.
Back to the volcanoes. But this time we're not talking about just any eruption. We're talking about the Deccan Traps in India.
Now, this is where things get really catastrophic. The Deccan Traps were a series of eruptions that spanned hundreds of thousands of years, spewing out just unbelievable amounts of lava and the gases.
It's hard to imagine the scale of it.
Just imagine a landscape completely consumed by flowing rivers of molten rock, ash clouds darkening the sky for miles and miles, and the air thick with toxic fumes. It was just devastation on a scale that's hard to even comprehend.
It sounds like something straight out of a disaster movie. Seriously, I can't even wrap my head around what it would have been like to witness such a thing. But did the Deccan Traps actually play a part in the extinction of the dinosaurs? I know there's been a lot of debate about that, right?
Yeah, for a long time, everyone thought the Chicxulub impact, that asteroid that hit the Yucatan Peninsula about 66 million years ago, that was considered to be the main culprit, the knockout punch for the dinosaurs.
Right, the asteroid gets all the attention.
But research is showing that these Deccan Trap eruptions, they might have had a much bigger impact than we first realized.
So it's not a simple case of asteroid equals dinosaur extinction.
Not that straightforward, no. The Deccan Traps were already erupting long before that asteroid came along, and they were releasing huge quantities of greenhouse gases, carbon dioxide, sulfur dioxide, all going straight into the atmosphere.
So the climate was already changing because of these eruptions.
Right. Global warming, ocean acidification. The ecosystem was under a lot of stress already. Then, bam, the asteroid hits.
Talk about a double whammy.
And that impact, it would trigger wildfires all over the planet, massive tsunamis, and this giant dust cloud that blocked out the sun, causing temperatures to plummet, like an instant ice age. This was the impact winter, and it would have devastated plant life. And of course, that had a ripple effect throughout the entire food chain.
So volcanic eruptions, and then a giant asteroid from space. Talk about bad luck. It seems like the dinosaurs just couldn't catch a break. But amid all this chaos and destruction, did anything manage to survive?
Well, we know the dinosaurs, at least the non-avian ones, didn't make it. But lots of other groups did. Mammals, for example, birds, reptiles, amphibians, fish, they all pulled through.
And it's those survivors that led to the world we know today.
Exactly. It's a perfect example of how, even though these extinction events are devastating, in the long run, they can lead to all sorts of new life and evolution. The dinosaurs disappearing created a chance for mammals to take center stage.
So in a weird way, the end of the dinosaurs was the start of something new.
Absolutely.
It's mind-blowing to think that the world we live in today, with all its diversity, came about because of these ancient extinction events.
It really highlights just how dynamic life on Earth is. It's always changing, always adapting, and finding new ways to survive.
So we've covered a lot of ground today, haven't we? From the Aptian to the Cenomanian-Turonian and finally the Maastrichtian, it's clear that these extinction events weren't just isolated incidents, but part of a much bigger story.
Yeah, the story of how life on Earth constantly changes and renews itself.
It reminds us that Earth has a long and incredibly dramatic history, full of twists and turns. And learning about these events from the past, well, it gives us valuable insight into the present and even what might happen in the future.
Absolutely, it's all connected.
So, deep divers, before we sign off, here's a little something to ponder. What if those massive volcanic eruptions hadn't happened? Could the dinosaurs have survived that asteroid impact? Or was their fate already sealed? It's a question that still has paleontologists scratching their heads. Until next time, keep on exploring the wonders of our planet's past.